Hello, Algebra students, and welcome to another lesson. We are continuing in section 8-5, and this is going to be a multiple day lesson. So this is day 1. What I'd like for you to be able to do by the end of this lesson is to factor a trinomial into two binomials when the leading coefficient is 1. And we're going to talk about what that means here in just a moment. So first of all, what is this factoring going to be like? Well, factoring is sort of like doing FOIL, but in reverse. So remember when we had these problems where maybe it said x plus 4 times 2x minus 3. And then we would FOIL that and we would say that was 2x squared minus 3x and then plus 8x minus 12. And that would get us 2x squared plus 5x minus 12. Well, what we did was take two binomials and turn it into a trinomial. Well, now what we want to do is take a trinomial, this has 3 parts, and turn it into two binomials. So we're doing FOIL in reverse. All right, so what are the steps to that? So the first step that we're going to do is find a pair of numbers that multiply to the last number and add to the middle number. Next, we're going to rewrite our middle term as two terms spread out. Then we're going to factor out the GCF of the first half and of the second half. We're going to rewrite and then we'll check our work. So you'll see those steps in action when we start jumping in. So here we have a trinomial. We have 1, 2, 3 terms. And our first step up here is to find a pair of numbers that multiply to the last and add to the middle. What does that mean? We're looking for numbers that multiply to 15 but add to 8. So what you can do over here to the side, you can just say, okay, I need multiples of 15. So when I find multiples of 15, that might be 1 times 15 or 3 times 5. 4 doesn't go in, but 5 does, so now we're back. So these are two pairs of multiples that are 15. Which pair also adds to this middle term, 8? So this 3 times 5 is my magic pairing because 3 times 5 is equal to 15, but also 3 plus 5, goodness gracious, you guys. 3 plus 5 is equal to 8. So it's meeting both of those requirements for us. All right, so what I'm going to do, I'm going to take these two values and I'm going to rewrite this middle term. So instead of writing 8x, I'm going to spread it out as 3 and 5. So I'm writing x squared, but now instead of 8x, I'm writing plus 5x, plus 3x, and then plus 15. So these two things have the same value. This 5 plus 3x reduces up to 8x, so I just spread it out. Okay, now it says for step 3, so we did step 1 and then we did step 2. Step 3, it says factor out the GCF of the first half and the GCF of the second half. So when we're looking at this, what we want to do is kind of look at this like the first half and the second half. I have x squared plus 5x for the first half. And then I have 3x plus 15 for the second half of this. And what I'm going to do is try to find the GCF or the biggest number in common with both of these. So looking at the first half, I have x squared plus 5x. What's the biggest thing that I can take out of both of these? Well, I can't take a number out, but they both do have an x in them. So I'm going to pull x to the front. But what's left over for the underlined yellow part, x squared with an x removed is x, and 5x with an x removed is 5. So I've got x plus 5 right there. So I just factored the yellow part, and I did not change the value of anything. If I were to multiply that out, I would still have x squared plus 5x. All right, now I'm going to take the GCF out of 3x plus 15. Well, what's the biggest number I can take out of this part underlined in blue? The biggest thing I can take out is a positive 3. So now what do I have left over if I divide a 3 out of the terms underlined in blue? 3x divided by 3 is x. 15 divided by 3 is 5. So I've got x plus 5. So I still have this first half and this second half of this problem. I still have the first half and I still have the second half. But notice that they have something in common now. We have these parentheses matching. I have this x plus 5 and this x plus 5. So I'm allowed to factor out that whole expression as well. So I'm going to rewrite, and so I have my x plus 5, that's what there is in common. And then what is left over when I pull x plus 5 out? I have an x from the yellow, and I have a plus 3 from the blue. And there are my factors. Now to check that, all you're going to want to do is quickly FOIL it back out. So if we come over to the side and just FOIL just to make sure. So I have x plus 5, x plus 3. If we FOIL, that's x squared plus 3x plus 5x plus 15, which gets me to x squared plus 8x plus 15. So it is correct. All right, that was kind of slow. We're going to do it again. So in example B, I have x squared plus 11x plus 24. I'm looking for things that multiply to 24 but add to 11. So we're going to come over here to the side and we're going to look for anything that can multiply to 24. So 1 times 24, 2 times 12, 3 times 8, 4 times 6. Those are all of our pairings. Now, which pair of these is also going to add to that middle number 11? Well, it's going to be 3 and 8. For 3 and 8, because 3 times 8 is equal to 24, and 3 plus 8 is equal to 11. There's my magic pairing. Now I want to rewrite my middle term with these two values instead of that 11. So I'm expanding this middle term into two numbers. So I have x squared plus 3x plus 8x plus 24. 3x plus 8x is the same thing as 11x, so I did not change the value of that. All right, now I'm going to factor out the GCF of the first half. The first half is x squared plus 3x, and the second half is 8x plus 24. So let's factor the front and back. So the biggest thing that I can take out of x squared and 3x is x. And then what do I have left over when I factor that x out? Well, x squared with an x factored out is x. 3x with an x factored out is plus 3. Now do the second part with the blue. Okay, I'm going to factor out a positive 8. Because 8 can be divided into 8x and 8 can be divided into 24. So now I have x plus 3. Still within those two halves, I have this x plus 3 in common now. Notice how those parentheses match. So I can rewrite this. The x plus 3 is in common, so I'm going to rewrite it with x plus 3. And then what is left over when I pull those out? I have an x from the first part, and I have a plus 8 from the second part. And those are my two factors. We're doing it again because I want to make sure that we're, just all on the same page. So here I have x squared plus 5x plus 6. We're looking for things that multiply to the last number and add to the middle number. So things that multiply to 6. 1 times 6 and 2 times 3. Those both multiply to 6. But which pair also adds to the middle number 5? Well, 2 and 3, because 2 times 3 is equal to 6, and 2 plus 3 is equal to, not 6, 5. Okay. So I'm going to take this 2 and 3, these factors, and I'm going to rewrite this 5x in the middle in expanded form. So I have x squared plus 2x plus 3x plus 6. The x squared stayed the same. The 5x became 2x and 3x. The 6 stayed the same. Now I'm looking at my first and half part of this expression. So the first part are the first two terms. The second part is the second two terms. Okay, now looking at that information, I'm finding the GCF of the first two terms. What's the biggest thing I can pull out of the terms underlined in yellow? I can pull an x out of both of those. So I'm going to write x and then write down what I have left over. When I pull an x out of both of those terms, I have x remaining and then plus 2. X squared with an x pulled out is x. 2x with an x pulled out is 2. Now you're going to find the GCF of the part underlined in blue. So I've got 3x plus 6. What's the largest thing that I can pull out of both 3x and 6? Well, I can pull a 3 out. So now what happens when I divide that 3 out? 3x divided by 3 is x. 6 divided by 3 is 2. So I've got plus 2. Now I still have this first half of the expression that I'm looking at, along with the second half of the expression that we are looking at. Okay, notice that they have something in common. They have this x plus 2 in common. Because they have that x plus 2 in common, I'm able to rewrite this. The x plus 2, I'm going to pull it out to the front. And then after I've factored out those parentheses, what do I have left over? For the yellow part, I have x left over. And then for the blue part, I have plus 3 left over. Those are my two factors. But we want to make sure that we, have the correct answer. So let's multiply these back out real fast. So I've got x plus 2 times x plus 3. Let's FOIL that. So x times x is x squared. X times 3 is 3x. 2 times x is 2x, and 2 times 3 is plus 6. But when I combine these middle terms, I have x squared plus 5x plus 6, and there's my value. All right, for that final example on the front page, I have example D, which says x squared plus 11x plus 18. What we're going to want to do is the same thing per usual. Find numbers that multiply to 18 and add to 11. So I've got 18 right here. That would be 1 times 18, 2 times 9, and 3 times 6. So those are all of our factors of 18. Now, which pairing of those is also going to add to 11? Well, I have 2 and 9 right here, so that's my magic pair. And I'm going to rewrite this middle term. This 11x is now getting broken down into 2x plus 9x. But we want to make sure we carry everything else down. So I've got x squared and then 18 in addition to that. All right, we've rewritten our expression and we're ready to factor from the first half, and then we're going to factor from the second half as well. All right, so looking at x squared plus 2x, what is the most that I can pull out of x squared and 2x? I can pull an x out of both of those. But when I factor x out of x squared, I have an x remaining. And when I factor x out of 2x, I have a 2 remaining. Okay, now factor the greatest common factor out of the part underlined in blue, or the back two terms. So positive 9 is the largest thing that I can pull out of that. And when I divide 9 out of both of those terms, I get x plus 2. That x plus 2 is common in the front half and the back half of this expression. So that means I'm able to just divide that out or factor that out of the expression now. So I have x plus 2, and I have x remaining, and then plus 9 remaining as well. Okay, so with all of these, we've had nothing but positive answers. What happens if we have some negative numbers? So what happens when we are factoring with negatives? For example, what if I had two minus signs in the problem, or a minus and then a plus, or a plus and then a minus. That's going to change some things up a little bit. We're going to do 3 of these examples, and then we'll work some more tomorrow in class. So in example 2, it says factor each expression, check your work. We are still doing the same process, but we now just have to be mindful of positives and negatives. In example A, we have x squared minus 11x plus 24. So we're going to need numbers that multiply to 24. Let me write that a better way. Multiply to 24, but we need them to add to negative 11. So how are we going to get two numbers that multiply to a positive number but add to a negative number? Well, they both need to be negative, because remember, a negative times a negative is a positive. So let's just find some numbers that multiply to 24 that are both negative. So negative 1 times negative 24, negative 2 times negative 12, and negative 3 times negative 8, and negative 4 times negative 6. Now I want to look at which pairing of those is going to combine to get me negative 11. All right, to get me negative 11 is the negative 3 and the negative 8. So now I'm just doing the same thing. I'm going to rewrite this middle term as negative 3x minus 8x. So let's do that. I have x squared minus 3x minus 8x plus 24. Now we're doing everything else exactly the same way. The only difference that we've got going on here is that we've got some negatives. So let's focus in on the first half, and then we're going to focus in on the second half. All right. So what is the largest thing that I can pull out of x squared minus 3x? I can factor out an x. But when I pull out that x GCF, what do I have left over? I have x minus 3. Okay, now this next part's a little funky. I have negative 8x plus 24. We don't want that leading number to be negative, so I know I'm going to have to pull out a negative number. And then out of 8 and 24, what's the largest number I can divide out of both of them? I can divide an 8 out. So now, what do I have left over when I divide negative 8 out? Well, negative 8x divided by negative 8 is positive x. 24 divided by negative 8 is negative 3. Okay, still looking at the first half and looking at the second half, we have the parentheses in common. So because those parentheses are in common, I'm going to pull them out to the front. So I have x minus 3. And then what do we have left over? We have an x left over in the yellow and a minus 8 left over in the blue. And there is our solution. So this is very, very, very similar to what we've been doing. It's just we've got some negatives in there. If we want to check our work real fast, then we can do that. X minus 3 times x minus 8. Let's FOIL. So we have x times x, which is x squared. X times negative 8, which is negative 8x. Negative 3 times x, which is minus 3x, and then negative 3 times negative 8, which is positive 24. When I combine the middle terms, I'm going to get x squared minus 11x plus 24, and notice that matches our original problem. Okay, we're going to do a couple more. These are still the same concept, just be mindful of negatives. So we need things that multiply to positive 8, but they add to negative 6. Okay, how do I have two things that are going to multiply to a positive number but add to a negative number? Well, they both need to be negative. So what are some multiples of 8 that are negative? Negative 1 times negative 8, and then negative 2 times negative 4. And that's all we've got. So which pairing is going to add to negative 6? It's going to be this pairing right here. So I'm going to take that negative 2 and that negative 4, and I'm going to rewrite this middle term. that negative 6x is becoming negative 2x minus 4x. But I've still got some other things in that expression. I've got this x squared and that 8, so I need to carry those down as well. Now I'm doing my factoring by grouping once again. So I'm going to group the first half with itself and the second half within itself. And what is the GCF of x squared minus 2x? Well, the most I can pull out of x squared minus 2x is x. And when I factor that out, what do I have left over? I have x minus 2. Now, looking at the second part, what is the most that I can pull out of the two terms underlined in blue? Well, negative 4x plus 8, I can pull out a negative 4. The reason I'm pulling out a negative 4 is because we don't like, for what's inside the parentheses, we don't like the x to be negative inside a parenthesis. So I'm going to pull out negative 4. And when I do that, negative 4x divided by negative 4 is x. And then positive 8 divided by negative 4 is negative 2. All right, so we are very close to finishing now. We have our first and second half. Notice how this x minus 2 is matching. So I can pull that x minus 2 to the front. And then I want to, so I factored out the parentheses. The yellow and the blue have the x minus 2 in common. But when I factor out those parentheses, what is left over? I have x and then minus 4. And there's our solution to problem B. We're just going to do one more and then the rest we'll do in class tomorrow. So for example C, I have x squared minus 8x minus 20. This one's a little bit different. Now I need numbers that multiply to negative 20, but they add to negative 8. Well, how on earth are we going to get two numbers that multiply to a negative number? One of the numbers is going to have to be positive, and one of the numbers is going to have to be negative. So, multiples of negative 20, that's going to be negative 1 and positive 20, or positive 1 and negative 20. It might also be negative 2 and positive 10, or positive 2 and negative 10. We could also have 4 times negative 6 or negative 4 times positive 6, and I believe that's all of them. So of these pairings, which one is going to add to this negative 8x? Well, we want to choose 2 and negative 10 because 2 times negative 10 is negative 20 and 2 plus negative 10 gets me negative 8. All right, so I'm going to use that magic pairing to rewrite this middle term. That negative 8x is now becoming 2x minus 10x. In particular, a positive 2x. But we want to carry down that minus 20 and that x squared. And now everything is like what we've been doing before. We're going to factor out the GCF from the first and second halves and then rewrite. So the GCF of x squared plus 2x is x. And then what do I have left over? So x squared divided by x is just x. And then 2x divided by x is just 2. Next, I have negative 10x minus 20. Well, what's the largest thing that I can divide out of both of those? I can divide negative 10 out of both of those. So now I have x plus 2. I get plus because negative divided by negative is a positive. Now that they have that x plus 2 in common, I can factor it out. So the first half, this first half underlined in yellow, and this second half underlined in blue, they have a common factor. That common factor is x plus 2. So I'm going to factor out the parentheses. And now what do I have left over? X minus 10. And those are our factors for problem C. That's all we're going to do in this note lesson. If you have questions, please bring them to me in class, and we will be spending multiple days on this. So you'll be able to have practice if you're feeling concerned about understanding for right now. All right, have a good night, and I'll see you later.